This is Biddeford High School Graduation Standard A5 Exponents. So for those of you watching this in Algebra 1, this is your first time looking at exponents. And if you are in Algebra 2, chances are you have seen this in your Algebra 1 class. If not, your Algebra 1 teacher probably did not have enough time to get to A5. Okay, so let's take a look at our Level 1 learning targets. I can identify the components of a power. So there are three basic parts. We have the base, the exponent, and the coefficient. Okay, so let's take a look at an example. Okay, so let's say we have this example 2x to the fourth. Okay, so as I'm sure you already know, we know what a coefficient is. So our coefficient is the number that is multiplied by our variable. Okay, so here we have our coefficient, which is 2. Okay, we have our exponent, which we know is this little number up here. It's to a power. And over here, last but not least, we have our base. Okay, so more often than not during the standard, we'll be dealing with the base as a variable. Okay, this is not always the case though. Okay, so let's say we had the expression 2 to the fourth. We didn't have an x here, we had 2 to the fourth power. In that case, the 2 would be our base. Okay. Alright, so let's take a look at some properties. So our level 2 here, I can use the following properties of exponents to simplify monomials. Okay, so we have the product of powers, quotient of powers, and zero exponents. Okay, so let's take a look at the power rule. So for a general expression, we have x to the a all to the b power. Okay, and it turns out this equals x to the a times b. Okay, so we just multiply that a and b and keep our base. Okay, so if we look at an example, we have x squared all to the fifth power. Okay, so let me rewrite this as x to the 2 times 5. Okay, just following this process over here. Okay, we know 2 times 5 is 10. So our solution would be x to the 10th power. Great, so let's go to the product power. Here we have 2 powers being multiplied. So we have x to the a times x to the b. Okay, as it turns out, this equals x to the a plus b. So let's look at an example. Let's say we have y cubed times y to the fourth. I'll rewrite that as y to the 3 plus 4. Okay, and we know 3 plus 4 is 7. So y to the 7th. Pause the video if you need more time. Okay, take a look at our quotient rule here. Okay, so here we have x to the a divided by x to the b. Okay, so we evaluate that as x to the a minus b. Okay, so our top power subtracted by our bottom power. And again, these bases have to be the same. So these need to both be x or both be y or both be the same number. Okay, so an example, let's say we have z to the 100th power, it's a big one, divided by z to the 6th power. Okay, I'll rewrite this as z to the 100 minus 6, which of course is z to the 94th power. So that would be our solution. Okay. We take a look at negative exponents now. Let's say we have x, for some generic situation, x to the negative a. Okay. Well, this is the same thing as 1 over x to the a. Okay, so we're just moving it down into the denominator and switching the sign of our power. Okay, so maybe this little rhyme will help you. Cross the line. Switch the sign. And of course, that's referring to our power. Okay, so if we look at an example, let's say we have w to the negative 12th. That's the same thing as 1 divided by w to the positive 12th. Now let's take a look at another example. Let's say we have r to the negative 3rd power divided by r to the negative 2nd power. Okay? So, let me change colors here. So, cross the line, switch the sign. So I have a negative exponent up here, so I'll bring it down here, crossing the line. But down here I also have a negative power. So I'll bring that up here, cross the line. Okay, so now that I've crossed that line, I can switch the sign. So this top expression, r to the negative 3rd power, comes down and turns positive. So we have r to the 3rd power. This bottom expression, r to the negative 2nd power, moves to the top and becomes r to the positive 2nd power. Okay, pause the video if you need more time. Okay, so let's take a look at the 0 power. So, generally, x to the 0th power equals 1. Okay? In fact, any expression to the 0th power equals 1. Okay? So we could have x to the 0th power, or y to the 0th power, or 2 to the 0th power, maybe even 100 to the 0th power. Always going to equal 1. Okay? So I know we're flying through this pretty fast, but there aren't very many rules with exponents. It's just, I find for exponents, it's a matter of practicing your skills. Okay? So, let's take a look here. So, level 3 already. I can apply the properties of exponents to simplify monomials. Okay? So, we have power of a power, power of a product, power of a quotient, and negative exponents. Okay, so we'll discuss all of those right now, if we haven't already. Okay, so some things to remember here. Oh, whoops. Sorry about that. So all the rules above will help us simplify expressions with exponents. Okay, so something to remember. Let me change color here. Okay, these rules only apply to expressions with similar bases. Okay, so just to reiterate that point, if we have x squared times y cubed, okay, this cannot be simplified. It's already in simplest terms. And why is that? It's because the bases are different. Okay? This expression has a base of x, this expression has a base of y. If they were both x, we would be able to use our product rule. Okay? But our bases are different, cannot be simplified. Okay, pause the video if you need more time. Alright, so let's take a look at some examples here, combining all of our rules from level 2 and 3. Okay, so use this one. So I have a power to a power, so I need to distribute this power to both my expressions here. Okay, so I have 4 to the third power times y to the 2 times 3. Okay, if you're confused as to how we got this, go back and check above. Okay, so we simplify 4 to the third power, that's 64, times y to the 6th. Okay, 2 times 3. Okay, so my final answer would be 64 y to the 6th. Awesome. Okay, let's go right over to this one right here. So, what I'm going to do is I'm going to write everything out. Okay, so this is the same thing as 2 times x to the 4th times y to the 4th times 4 times y cubed. Okay. So what I'm going to do now, I'm going to underline all my like bases. Okay. So right here I have a 2, and over here I have a 4. Okay. I know that I can multiply those two numbers together. Okay. 2 times 4, that's possible. So that equals 8. Okay. So now I'm going to do my x's next. Okay. So I've got one x right there as my base. So I'll keep looking through here. No other expressions with a base of x. So I'll just bring it down. Okay. Switch colors one more time. So next I have y to the fourth, so I'll underline that with this color. Okay, I'll continue to look through my expression and look right there. I have another expression that has a base of y. So these two terms are being multiplied, so I need to use the product rule. Okay, so y to the 4 plus 3. Okay, so if we simplify all of this down, 8 cannot be simplified, so it will remain in our solution. X to the fourth cannot be simplified, so it will remain in our solution. And then we have y to the 4 plus 3. Well, of course, that's y to the 7th. So that is our solution. Okay, so let's move right down here. I'll do the same thing. I'll just rewrite this expression. So down bottom I have v squared. That won't change. Up top here I have 2 times v to the fourth times 3 times v cubed times 4 times v to the fourth again. Okay, so what I'll do, change colors here. I'll do my integers first, so I have a 2 right there, I have a 3 right there, and I have a 4 right there. Okay, so 2 times 3 times 4, well 2 times 3 is 6. If I multiply that by 4, I get 24. Okay, multiplication sign. Go to my next color. So this expression has a base of v, so I'll underline this one. So does this one, and so does this one. Okay, so what I will do now, I'll write my base of v, and of course we have the product property here. Okay, so we have 4, 3, and 4. So v to the fourth plus 3 plus 4. Okay, and of course this is all divided by this v squared. Don't forget about that. Okay, so right here, this equals 24 v, 4 plus 3 is 7, plus 4 is 11, over v squared. Okay, so am I done here? No, I'm not done. Okay, I have v's in my numerator and I have v's in my denominator. Okay, so I need to simplify this now. So using my quotient rule, I know that I can rewrite this as 24 v to the 11 minus 2. Okay, and of course this equals 24 v to the 9th. Awesome. Okay, so let's take a look at my next one. So I have a p divided by 4p to the negative second power. So first off, I'll rewrite this. Okay, I have p divided by 4 times p to the negative 2. Extend this a little bit. Okay, so I have a negative exponent here. So what I'm going to do, I'm going to cross the line and switch the sign. Okay, so I'll draw an arrow up here. So I have this p already up here, times this p to the negative second power comes up and the sign switches. So p squared. And then we have this 4 down here. Okay? If we just have a number like 4, okay, this is to the first power. Okay? But of course we do not need to write that. Okay, so using the product property, if our base does not have a visible exponent, okay, we say that it has a power of 1 as well. So this is the same thing as p to the 1 plus 2 divided by 4. Okay, so this equals p cubed divided by 4. Okay, pause the video if you need more time. Okay, so let's take a look at these ones down here. Okay, so what I'm going to do here, I have x squared times xy all to the 0th power. Okay, so I'll take this expression right in here and I'm just going to rewrite it. Okay, so I have my parentheses. I have x squared times x times y. Again, all to the 0th power. Okay, so I'm going to combine these x's right here using the product property. So I have x to the 2 plus 1 times y. Again, to the 0th power. So this equals x cubed times y to the 0th power. So at this point what I need to do, I need to distribute the 0 through. Okay? So it's going to hit both expressions. So we are left with x, again, power rule here, x to the 3 times 0 times y to the 1 times 0. Okay? So this equals x to the 0th power, y to the 0th power. Okay? And as we know, anything to the 0th power is 1, so we have 1 times 1, which of course leaves us with 1. Okay? So now that we've gone through the steps of solving an expression to the 0th power, we can take a shortcut here, okay? So this entire expression is to the 0th power. Well, I can look at this entire expression and know that this process down here is going to happen where that 0 is distributed through. So I can automatically just say, by looking at this, the answer is 1. Okay? So let's take a look at this next one. So I'm not going to touch this expression over here. I'm going to worry about my parentheses first. Okay? So I know this 3 needs to be distributed to all 3 terms here. Okay? So I have 5 cubed times x to the negative 4 times 3. That's negative 12. And then y cubed to the 3rd power. That's y to the 9th. Okay? So now I can tack on this expression over here. So I have times x to the 4th times y to the negative 3. Okay? So what I'm going to do now, I'm going to underline like bases. So I have 5 to the 3rd power. So 5 times 5 times 5, that's 125. Okay, so now I'll do my x's. I have x to the negative 12th and x to the 4th. Okay, so that's the same thing as x to the negative 12 plus 4. Now I'll do my y's. Y to the ninth and y to the negative third. So I have y to the ninth plus parentheses negative 3. Okay, so now I'll simplify. This 125 cannot be simplified. I have x to the negative 12 plus 4. Negative 12 plus 4 is negative 8. Okay, and I have y to the 9 plus negative 3. Well, because we have a plus sign here and a minus sign here, that becomes negative, so 9 minus 3, that is positive 6. So, are we done? No, we're not. We have a negative exponent, and we want all positive exponents. So, what am I going to do with that negative exponent? I'm going to cross the line and switch the sign. So first off, I'm going to write everything that stays above our line. So I have 125, because that has positive exponents, and I have y to the 6th. So this x to the negative 8th, it goes to the denominator. Sign becomes positive. So that is our final answer. Perfect. Okay, pause the video if you need more time. Right, so let's take a look at these ones. Okay, so if we have the quotient rule that also has a power rule attached to it, okay, or a fraction to an exponent, one rule to remember is this second power right here, I'm just using this expression as an example, needs to be multiplied through to the top and bottom. Okay, common mistake there. So, does it matter if we simplify the expressions inside the parentheses first and then go through with our powers? No, it doesn't. There's not necessarily an order of operations for solving exponents. So, what I'll do it the long way. Okay, so just so we see what it looks like. Again, go into this expression and that expression. I have a to the 7 times 2 divided by b to the 3 times 2, okay, times, again, this 3 will go to both expressions, b to the negative 5 times 3 divided by a cubed times 3. Okay, so we simplify here, we get a to the 14 divided by b to the 6th. And then we have times b to the negative 15 divided by a to the 9th. Okay, so at this point right here, knowing my properties of fractions, or my operations of fractions, I know I can multiply across the numerator and multiply across the denominator. So I'm going to do that. So I'll rewrite this as a to the 14th times b to the negative 15th divided by b to the 6th a to the 9th. Okay? So, using my quotient rule, this equals, I'll focus on my a's first. So I have a to the 14 minus 9 times b to the negative 15 minus 6. Okay, so here, just some simple math. This equals a to the fifth, b to the negative 21st. Okay, so I'll write my positive exponents up here, make my line, and this b to the negative 21st power, it's going to cross the line and switch the sign. So this becomes b to the 21st. Okay, final answer. Alright, so this one over here, I'm going to deal with these two expressions separately. So I'll deal with the top first and then the bottom. So if I rewrite the top, it is n times m to the 0th times m squared times p to the negative 3. Okay, so when I simplify this, okay, just quickly, I can say n times m to the 0 is 1 times m squared times p to the negative 3rd power. Okay, so at this point what I'll do, I'll just get rid of this 1, okay, because it does not need to be there. So I have n times m squared times p to the negative 3. So now I'll deal with the bottom. So, looking at the bottom, I will distribute this 3rd power to all of my expressions. Okay, so 1, 2, 3, 4. So I can write this as 2 cubed times n cubed times m to the negative 1 times 3, so negative 3, okay? And then I have p to the 4th power to the 3rd power, all to the 3rd power. So 4 times 3 is p to the 12th. Okay? So what I'll do here is just simplify. 2 to the 3rd power, that's 8. Okay? And then I have times n cubed times m to the negative 3 times p to the 12th. Okay? So now I have this expression right here, my top simplified, and I have my bottom simplified. So I'll just rewrite everything. So I have n times m squared times p to the negative 3, all divided by 8 times n cubed times m to the negative 3 times p to the 12th. Okay, so what I'll do here, I will keep my powers where they are, or my expressions where they are, unless they have a negative. Then I'll cross the line and switch the sign. So this p to the negative 3rd power has to come to the bottom, and this m to the negative 3rd power has to go to the top. So I have n times m squared times m cubed divided by 8 times n cubed times p to the 12th times p cubed. Okay, so all we need to do now are combine our like bases, and then we're all set. So I have up top n and we have m squared times m cubed, so we know that is 2 plus 3, so m to the 5th, divided by 8n cubed p, product rule here, we have p to the 12th times p cubed, 12 plus 3 is 15. Okay, so are we done here? No, we're not. Okay, we can simplify a little bit more. So we have an n in the numerator and an n cubed in the denominator. So what are we going to do? Okay, so we know that this is n to the first power, and down here we have n cubed. So we would do, or according to the quotient rule, we would say n to the 1 minus 3. Well, that's negative 2. So we would have n to the negative 2 up here. So we will take that n to the negative 2, cross the line, switch the sign. So we're left with, up top, m to the 5th divided by 8 n squared now, p to the 15th. Okay. Again, this one looks really complicated right from the start, but we just broke it down step by step. We didn't tackle it all at once, and we came out to a nice solution. Okay, pause the video if you need more time. Okay, last two for this video. So let's take a look at these last two examples. Uh-oh. Okay, so you need to take this 3 and apply it to both expressions. Same with this negative 2. Okay, so if I rewrite this, I have a to the 2 times 3 divided by b to the 4 times 3. Okay, and over here I have a to the 4 times negative 2 divided by b to the 1 times negative 2. Okay, so I'll simplify this expression. I have a to the 6th divided by b to the 12th. In this expression, 4 times negative 2 is negative 8, so I have a to the negative 8 divided by b to the negative 2. Okay, so knowing my operations of fractions, I can rewrite this as a to the 6th, a to the negative 8 divided by b to the 12th, b to the negative 2. Okay, so I'm going to combine like bases. So I have a to the 6 plus negative 8 divided by b to the 12 plus negative 2. So this is the same thing as a to the 6 minus 8, again because of our sign difference there. For the same reason, we have b to the 10th. Okay, so 12 minus 2. So I should have just rewritten this top. So I have a to the negative 2 divided by b to the 10th. Okay, so my last step, I have a negative exponent in my numerator, so I'm going to change the sign, or cross the line and switch the sign. So this a to the negative 2 comes down here. So I'm left with 1 divided by a squared b to the 10th. Okay. one last problem here. So, again, looks a little tricky, but let's just break it down. So, I'll deal with my parentheses first. So I'll multiply by this -2 in all expressions. So up top, I'm left with m to the -1 n squared divided by, okay, so I'm going to rewrite this as -1, okay, because this is a negative n, so same thing as -1 times n, times n times m to the -3rd, okay, and then of course I have my second part of my expression down here, -2 m to the 4th n cubed. Okay, so, sorry, I forgot my -2 up here. So now I'll distribute this -2 through. So I have, if I'm looking at just the bottom, okay, I have -1 to the -2 times n to the -2 times m to the 6th. And of course I have my times -2 m to the 4th n cubed. So what I'll do here, combine some like terms. So I end up having, I'll keep my -1 to the -2 over here, okay? I have my n's, okay? So n to the -2 times n cubed, so -2 plus 3, we've got the power rule. That leaves me with n. Okay, I'll do my m's next. So I have m to the 6th and m to the 4th. So of course that's m to the 6 plus 4, which is 10. Okay, and then I'll just tackle on my times -2. Okay, so now let me rewrite my entire expression now. So I have m to the -1 n squared divided by -1 to the -2nd power n m to the 10th. I'll write my -2 out front, just looks better up there. Okay, so now what I'll do, I'll look at my negative exponents, I'll cross the line, flip the sign, okay, so this m to the -1 will come down bottom, this -1 to the -2nd power will go up top. So I have -1 to the positive 2nd power times n squared divided by -2 n, and then this m to the -1st power will come down to the denominator, changing it to m to the positive 1st power. So then I can use the product rule. So I have m to the 1st power times m to the 10th power. So that's m to the 11th. Okay? If you're confused about that, just come talk to me. I can explain that a little more in depth. Okay? So, -1 to the 2nd power, that turns out to just be 1. So I'm left with n squared divided by -2 n m to the 11th. Okay, so am I done here? No, I have n squared in the numerator and I have an n in the denominator. So 2 minus 1, that's 1. So I'll have 1 n in the numerator. I have negative 2 m to the 11th in the denominator. So again, are there a lot of rules to these types of problems, to simplifying exponents? No, there's not a whole lot of rules, but they can get tricky and complicated. So just take it one step at a time, practice a lot, and don't rush any formatives or summatives, okay? The more practice, the better.